Hey guys, welcome back. Today we want to cover OOP, in other words, object-oriented programming. Congratulations, if you've made it this far, it means that you've covered the basics in Python. If you've done all the practice and you've been through the tasks, that means that you should be quite confident in what you're doing. And double congratulations, because everything going forward doesn't get harder, actually, it gets easier. So at this point then, everything that we do going forward should help you become a better programmer who programs more efficiently. So, what is an object? What is a class? A class, I want us to imagine, is a way for us to create an object which has its own attributes, its own variables, in other words, and its own functions, or otherwise known in a class as methods. So, as an example, on the right hand side of my slide, I've got a blueprint for what I'm going to say a doll looks like. So a doll will have its own eye color, its height, its hair color, and that would be its attributes. And then it would have its own methods. So in other words, functions such as walking, running, turning left or turning right. Now, up to this point, whenever I've asked you to name a variable or to a function or a procedure, we've always said that you should name these objects beginning with a lowercase letter. That is because anytime we have a object that begins with an uppercase letter, unless it's a constant, which is all caps, then we know that what we're looking at is a class. And in this case then, when we create our class, you can see here I've got the word doll with a capital D. And if my word was to have more than, if the name of my class was to have more than one word, then we would use camel casing. So this is a naming convention so that when we look at our objects, we have an idea of what they are. Right, so like I said, when we create an object, the object itself will have its own attributes and it will have its own methods. And what's really interesting is they can communicate with each other and we can communicate with them. So to demonstrate this, my example here is that I've got the doll class. Oh, by the way, I've just got pass written here instead of the attributes and things like that. And the pass method is just a placeholder to say that more code will come later. And this will stop our Python code from crashing. So what I've done is I've instantiated, or in other words, I've created an object using the doll class, and I've saved it under the variable A. And I've done the same here and saved another doll object under the variable B. So if I was to print A equals B, what do you think I'd get? Would it say true? Knowing that they're both exactly the same, we use the same blueprint to create them, should the answer be the same? Here when I run this, the answer is false, and there's a reason for that. And that's because every time we create the object, like we said, we're storing that variable containing the class in the RAM. Okay, that's rudimentarily, oh, that's really bad. And what I'm doing is I'm saving that in one area of the RAM, and I'm saving that in another location of the RAM. So they're both independent from each other. And that's why we said they can communicate with each other and we can communicate with them. But because they're both in separate RAM spaces, even though they may be identical, they operate separately. So they're separate entities. Right, now that we've removed the pass from our object, from our blueprint, our class, should I say, we have what's known as a constructor method. In Python, that's known as the initializer. But in your exam, you're going to refer to that as a constructor method. And what that basically does is, it gives the object particular attributes at the time that it's created. So when we first create our object and we save it under a variable name, we're also going to pass two attributes, name and eye color. And what that will do is that will save name as self name. So it will give itself a name, and that's why we refer to the keyword self. And it will do the same with eye color. So it can refer to its own eye color as itself's eye color. Here's an example of that. In this example, I've instantiated a doll under the variable Alex, and I've referred to it, I've given it the attributes of Alex as a name and brown as an eye color. So in this example, I have two more, and I'm demonstrating something called the dot method. So here you can see that where we have alex.name, what we're doing is we're referring to the first instantiated object, Alex. So what we're doing here using the dot method, as you can see, there's a dot there. Using the instantiated object name, so alex.name, allows me to access the attributes in that sense. Here I'm also saying alex.iColor. So that would, then the doll itself, sorry, I'm saying doll. The instantiated object Alex will refer to itself and can access its own iColor and its own name. So if I was to print this line out and then this line out, the output should be Alex has brown eyes, Ali has hazel eyes. Let's do another example. So here then, I want to say I want to create a blueprint for a car. So I'm going to say the car, and I should give the car a constructor method. So we'll say init underscore underscore, it needs to refer to self. And let's pass through model, and let's pass through color, and let's pass through doors. Right, so if I do that, I now have to refer to three objects, three attributes here. So we're going to say self.model is equal to the model argument that's going to be passed. Self.color is going to refer to color, and self.doors is going to be equal to doors. Right, so now if I instantiate an object, so this is my blueprint for how I'm going to create a car. Now I want to be able to create a car using that blueprint. So I'm going to say polo equals car, and I'm going to pass through three arguments. So the first one is going to be VW polo. Then we'll say this is silver, and we'll say that this car has, in fact, it's not a string, this has 3 doors. And let's do the same one more time. So we'll say Corsa equals car. So we're using the car blueprint again. And we'll say Vauxhall, Vauxhall 2 L's, Vauxhall Corsa. And we'll say this car is black. And then we'll say this has 5 doors. And actually I should make that lowercase, because I'm going to put it in part of a sentence. Okay, so now I'll try that out, right? So now I'll print using the dot method that I mentioned. I'm going to say, all right, polo dot. In fact, let's put it into a sentence. Sorry. Let's say the polo dot model has, no, it is a polo dot color and has polo dot doors. So I know that's a bit long. Let's try run this and see how it looks. So if we run that, it should say the VW Polo is a silver. Oh, I should say is a silver and has 3 doors. And it should be exactly the same if I was to do it for the Vauxhall Corsa. So this is kind of everything I want to show you to begin with when it comes to classes. So there is a few more things to look at. So next we'll be looking at inheritance, and we'll be looking at polymorphism. But to begin with, as always, guys, I have some tasks for you. They're linked to the video below. Try them out, practice, and I'll see you in the next video where we'll continue learning a bit more about OOP. See you in the next video.